Bismillahirrahmanirrahim. So today we are going to discuss about the null hypothesis, why it is important. Basically, the purpose of hypothesis is to facilitate a particular conclusion about the true population, and in this regard we use sample proportion in a population, and then we test this hypothesis and infer those findings in the population. Uh, Before we begin with one example, let's assume that we want to understand that let's say all Chinese boys have black color hairs, and if in order to establish this phenomena that all Chinese have black color hairs, if we say that our hypothesis is that all Chinese have black color hairs, and we screen, let's say, 1 billion individuals in that population, and we see all of them are black in color, so would we be able to establish this with certainty? In case there is one guy who just appeared and he has a gray hairs, then our hypothesis stands refute. So the best strategy to establish this link of black color of hair with Chinese is to refute the idea and to present it that we see that there is no association of black color hairs with Chinese, and then we screen a certain proportion of population. If we see that the number of individuals who have a black color have association with Chinese, then we establish this phenomenon that look, our null hypothesis stay refuted. Okay, similar thing is happening with the treatment plan. Suppose we want to establish this phenomena that in a trial on prostate cancer, 218 patients were randomly assigned either novel or standard treatment, and we want to see whether the novel treatment has any advantage over the standard treatment, and we see that after 1 year how many number of individuals remain alive. So by looking at the table we can see that 69 individuals are alive in novel treatment as compared to the standard treatment plan where 45 individuals are alive out of total 110 individuals. So, the first foremost thing would be, what is our hypothesis? Our hypothesis would be that novel treatment is superior or inferior. In this case of novel treatment, superiority or inferiority, we will be in what you can say in extreme trouble if we establish this in a very layman language, that the novel treatment or the treatment which is now recently established has some preferential advantage over standard treatment. But we do a smart trick and we say that there is no difference between standard and novel treatment. Now, if there is no difference between standard and new treatment, we just need to prove that the null hypothesis is void or is not true. Okay, so both treatments does not have any significant difference, or we can say they are both equally effective. So that's the trick we use null hypothesis for. So similarly, let's say in a veterinary in vitro fertilization clinic, the choice of seeking Tom and Queen cat is not different, because we are already saying that the probability of one sample to be male is 0.5%, and then the probability of first and second sample to be both should be male are is equal to zero point 0.5 into zero point 0.5 is equal to 0.25 probability. It's again the same thing, which is like tossing for head and coin, head and tail version in a coin. Okay, so the probability that first sample will be male is equal to zero point 0.5. I mean, there is a 50% chance that it could be either a male kitten or it could be a female kitten. The male kitten is called Tom, the female kitten is called as Queen. Pretty straightforward. So if we count the probabilities and we extend this probability of obtaining 5 males, then the probability value is saying that 0.03125 is the probability of obtaining male kittens from a cat in using in vitro fertilization. So our prime objective is, in hypothesis in this case, would be that there is no difference of seeking male or female from in vitro fertilization facility in a clinic. There is equal chance that we can get male kitten or we can get a female kitten according to null hypothesis. But based on the statistical data we are doing the probability evaluations, we come to know that the obtaining of 5 male kittens out of 5 full-term pregnancies in a cat is 0.03125. So that's mean there is a very low likelihood that the individuals we are obtaining would be having the males since 5 runs. And if we notice this phenomena, we say that the null hypothesis is extremely wide. So if the p-values, the probability values are generally written as capital P's, but in literature we usually write it as small p's, which is actually representing sample proportion. It is misnormally presented, but if capital P is exceeding zero point 0.1, greater than zero point 0.1, it means that the results are reasonably consistent with the null hypothesis. And if p-value is equal to 0.05, there is a moderate evidence that against the null hypothesis. 0.05 means that there is a 5% probability that the individuals we are seeing may have some variations in compared to the null hypothesis as well. But if we see the probability value is much less, as example is 0.001, that means there is only 1.1% chance that there is a strong evidence against the null hypothesis. Out of 100, there is 1% strong evidence against the null hypothesis. So if we assume our case over here that says that 0.03125, the value falls somewhere over here. So there is a significant value, and it says that the chances of our earlier statement of null hypothesis is refuted. So in vitro fertilization clinics, the chances of controlling male or female progeny is also governed by the clinicians itself. All right, so we just need to establish this phenomena by indirectly proposing this, that the chances of getting male and female is equal. That's the trick, and this is how we do the experiments. Thank you very much for your time and attention.